Ever stop to think about how the internet connects us, how phone calls travel across the world in seconds, or how high-definition videos stream seamlessly to your devices? Well, the answer lies in a groundbreaking technology called fiber optics. Fiber optics is the invisible force powering our modern lives, from high-speed internet to life-saving medical procedures. But what exactly is fiber optics? Where is it used, and why is it so important in today's world? In this video, we'll uncover everything you need to know about fiber optics, how it works, its real-world applications, and when and where it plays a crucial role in our daily lives. By the end, you'll see why fiber optics is the backbone of modern communication and how it is shaping the future. Let's get started. Fiber optics is a technology that uses thin strands of glass or plastic fibers to transmit data as light signals over long distances. These fibers are incredibly thin, about the diameter of a human hair, but are capable of carrying massive amounts of data at lightning-fast speeds. The concept behind fiber optics is simple yet brilliant. Data, such as internet traffic or phone calls, is converted into light signals. These light signals travel through the fiber, bouncing off its walls via a process called total internal reflection. At the other end, the light signals are converted back into electronic data. Fiber optics relies on light, rather than electricity, to transmit information. This makes it much faster, more reliable, and less prone to interference compared to traditional copper cables. The technology was first introduced in the 1960s, but it wasn't until the 1980s that fiber optics became widely used in telecommunications. Today, it's the foundation of high-speed internet, cable TV, medical imaging, and even space exploration. To understand how fiber optics works, let's break it down step by step. Fiber optic cables consist of several layers that work together to transmit light signals effectively. Here's what's inside. 1. Core. The central part of the fiber, made of ultra-pure glass or plastic, where the light travels. 2. Cladding. Surrounding the core, the cladding reflects light back into the core to prevent it from escaping. 3. Buffer coating. A protective layer that shields the fiber from damage, like moisture or physical stress. 4. Outer jacket. The final layer that protects the entire cable from environmental factors. The magic of fiber optics lies in total internal reflection. When light enters the fiber at a specific angle, it bounces off the walls of the cladding without escaping. This allows the light to travel long distances with minimal loss. Think of it like a game of ping pong, but inside a tiny tube of glass. Here's how it works in practice. 1. A transmitter, like a laser or LED, converts data into light pulses. 2. These light pulses travel through the core, bouncing along its length. 3. At the receiving end, a detector converts the light pulses back into electronic data. There are two main types of fiber optic cables. 1. Single-mode fiber, SMF, transmits a single light wave. Best for long-distance communication, such as undersea cables or intercontinental data transfer. Used in applications like 5G networks and global internet infrastructure. 2. Multi-mode fiber, MMF, transmits multiple light waves simultaneously. Ideal for short-distance communication, like within buildings or data centers. More affordable, but less efficient over long distances. One of the biggest advantages of fiber optics is its speed and bandwidth. Fiber optic cables can transmit data at speeds close to the speed of light and handle enormous amounts of data simultaneously. This makes them perfect for today's demanding applications like streaming, gaming, and cloud computing. Fiber optics is everywhere, even if you don't see it. Here are some of the most common and impactful applications of fiber optics in our world. Fiber optics is the backbone of modern telecommunications. Whether you're streaming a movie on Netflix, making a video call on Zoom, or browsing social media, fiber optics is what makes it all possible. High-speed internet. Fiber optics provides faster, more reliable internet connections compared to traditional copper cables. It's the technology behind fiber-to-the-home, FTTH, services like Google Fiber or Verizon FiOS. 5G networks. Fiber optics is essential for connecting 5G cell towers, enabling ultra-fast mobile internet speeds. Undersea communication cables. Did you know that over 95% of international data travels through fiber optic cables laid on the ocean floor? These cables connect continents and power the global internet. Fiber optics powers cable TV and streaming services, delivering high-definition video and audio to millions of homes. Its high bandwidth ensures smooth streaming without buffering, even during peak usage hours. Fiber optics is the lifeline of data centers, where massive amounts of data are stored and processed. With companies like Google, Amazon, and Microsoft relying on cloud computing, fiber optics plays a crucial role in connecting servers and ensuring fast data transfer. In the medical field, fiber optics is used in a variety of life-saving technologies. Endoscopy. Tiny fiber optic cameras allow doctors to see inside the human body without invasive surgery. Laser surgery. Fiber optics is used to deliver precise laser beams for surgeries, such as eye correction. Biomedical sensors. Fiber optics enables real-time monitoring of vital signs and medical conditions. Fiber optics is widely used in military and aerospace applications due to its reliability and security. Secure communication. Fiber optics is harder to intercept, making it ideal for encrypted military communication. Weapons systems. It's used in advanced missile guidance systems. Space exploration. Fiber optics enables data transmission in spacecraft and satellites, even in extreme environments. Fiber optics is the backbone of smart cities, where connected devices and sensors work together to improve urban life. Traffic monitoring. Fiber optics helps manage traffic flow and reduce congestion. Security systems. It powers high-definition surveillance cameras and alarm systems. Smart grids. Fiber optics enables efficient energy management in smart grids. In factories and industrial facilities, fiber optics is used for machine communication. Fiber optics ensures fast and reliable communication between machines. Robotics. It powers the sensors and controls in advanced robotic systems. Process monitoring. Fiber optic sensors are used to monitor temperature, pressure, and other variables in real time. Fiber optics isn't always the best choice for every situation, so let's discuss when and why it's used. Fiber optics is the go-to choice when speed and bandwidth are top priorities. For example, streaming high-definition videos without buffering. Online gaming, where low latency is crucial. Transferring large files or running data-heavy applications. Cloud computing, where fast data transfer is essential. Fiber optics is ideal for long-distance communication because it experiences minimal signal loss. It's used for connecting continents via undersea cables, providing internet to remote or rural areas, building backbone networks for telecommunications. Fiber optics is much harder to tap into compared to copper cables, making it the preferred choice for secure communication, such as military and government networks, financial institutions and banks. Encrypted communication systems. Fiber optics is less affected by environmental factors, such as electrical interference or weather conditions, making it ideal for industrial automation and factory communication, medical equipment and monitoring systems, critical infrastructure like power grids and transportation networks. While fiber optics is an amazing technology, it's not without its challenges. Here are some of the key limitations. Installing fiber optic networks can be expensive, especially in rural or remote areas. The cost of materials, labor, and specialized equipment can add up quickly. Fiber optic cables are more fragile than copper wires and require careful handling during installation and maintenance. Fiber optics requires skilled technicians for installation, splicing, and maintenance, which can increase operational costs. Fiber optics isn't always compatible with older technologies, which means upgrading to fiber optic systems may require additional investment. The future of fiber optics is brighter than ever. Here's what we can expect in the coming years. Fiber optics will play a crucial role in the development of 6G networks, offering even faster speeds and lower latency. Governments and companies are working to bring fiber optic internet to rural and underserved areas, bridging the digital divide. Researchers are exploring the use of fiber optics for quantum communication, which could revolutionize secure data transmission. Fiber optics will power the next generation of smart cities, enabling real-time data collection and AI-driven decision-making. Fiber optics is truly one of the most transformative technologies of our time. From powering the internet to enabling life-saving medical procedures, it's hard to imagine our modern world without it. As we move into a future of 6G networks, smart cities, and quantum communication, fiber optics will continue to play a critical role in shaping how we live, work, and connect. Now it's your turn. Did you learn something new about fiber optics today? Or do you have questions about how it works? Drop them in the comments below. I'd love to hear from you. If you enjoyed this video, don't forget to like, subscribe, and hit the notification bell for more tech deep dives like this. This Tech in Minute. Until next time, stay curious and keep exploring.